and subtracting. No. Rational expressions. So let's start with LCM, because we know that to add or subtract fractions, we need common denominators, which means finding the least common denominator, which is the least common multiple of the denominators. So when we start talking about getting common denominators, we always start with how to find the LCM. When we do it with numbers, we've done this before, so we've said, like, get my hands working this morning. Okay, so find the LCM of, like 15, 18, and like, I don't know, 24. Whenever I make one up, my LCM is always the same. So what do? You guys tell me.
3, 5 for 15.
So do prime factorization. Good. So 15 is 3 times 5.
18 is
2 times 3 times 3. You're thinking 16.
yeah.
And then 24 is 2 times 2 times 2 times 3.
And you had common factors.
So remember, GCF was all the ones they had in common.
Right. So you need a 3 and a 5. And 3 2s, 2 3s.
So we started with the factorization of the first one, and then we said, okay, we need a 2. If we look at the second one, we need a 2 and we need 2 3s. So a 2, and then we already have 1 3, so we need 1 additional 3. And then here we need 3 2s and 1 3. We already have 1 factor of 2, so we need 2 more factors of 2. And then we already have that factor of 3. And it's 900.
360.
No, yeah, 360. Which doesn't really matter at this point. We just care about how we get there. So does everybody remember that? Any questions on just that basic process? So now we're going to do it with polynomials. So we're going to find the LCM of, say, x squared plus 2x plus 1, 5x squared minus 5x, and x squared minus 1. So just like we talked about on Thursday, remember, we're thinking of each one of these polynomials individually in the same way as we think of a single whole number. We're working with whole numbers. So we're going to factor each of those polynomials. So we've got x squared plus 2x plus 1. If you do your AC method, you will get x plus 1 times x plus 1. And then 5x squared minus 5x. That's just got an LCM, or sorry, a GCF of 5x. So we get 5x times x minus 1. And then x squared minus 1 is x plus 1 times x minus 1. And so now we're going to build that LCM in the same way we did with whole numbers. We're just going to start with the first factorization, which in this case is x plus 1 times x plus 1. So we got these two. And then that second factorization has a factor of 5, a factor... Be quiet. A factor of 5, a factor of x, and a factor of x minus 1. And I don't have any of those factors at this point, because at this point I only have factors of x plus 1. So I need all of those. So 5x times x minus 1. Then when we get to the third polynomial, we say, okay, I need a factor of x plus 1, but we already have one here. And we need a factor of x minus 1, but again, we already have one. So we don't need any additional factors to account for that last polynomial. And so this is our LCM. We might write it a little nicer, like... No, we didn't cancel anything. We just moved stuff around. Because it's not a, there's no fractions here, so we can't cancel anything. I just moved it around to make it look nicer. Okay, here's one for you guys to try. Find the LCM of let's do x squared minus 1 and x squared. I think you started writing this one, and then started writing it again.
Mm. Yeah, looks like that's what it is.
That would have made things messy. So remember to group your polynomials. So you're looking at individual terms. You want the entire polynomial. So double check your factorization before you move on to actually writing your LCM, just to make sure that you're working with the right factors. Okay, so we'll start again with that first factorization, which is x plus 1 times x minus 1. And then what additional factors do I need from the second factorization?
X plus 2.
I need x plus 2 and an x, which I'm just going to go ahead and put right here. And then do I need any additional factors from the third one? Yeah, I need another factor of x, right? So call that x squared.
I think you can leave the x squared as x squared, right?
Sure, as long as you recognize that you don't need an x and an x squared. Any questions? Did everybody get this? Well, I mean, that's how you find the LCM.
Yeah, but that's not the...
So we all good on this one? Yes.
I'm just wondering why there isn't an x plus 1 squared.
Up here?
The LCM, because there's two. I might have missed that. You mentioned it.
Are you talking
Yeah.
about it? This one?
On the problem that we just did.
Yeah.
Yeah. There's two x plus 1s.
Right, but there aren't any. We don't take all the factors. We just have to have each of the factorizations accounted for in our LCM. So
So if there's a common one, you just kind of disregard that one. Or?
well, it's not that we're disregarding it; it's that it's already there. If something's already there, we don't need to put it there again. So that's our first polynomial. And then our second polynomial is there's an x in there. We only need one of those x's from the x squared. And then there's our third one. So the LCM is a multiple of each of them. It's not all of them multiplied together. It just has to contain the factorizations of each polynomial. Other questions? Okay, so let's start adding and subtracting. Like I said on Thursday, doing a lot of this correctly has to do with just organization. There's quite a bit going on, and so if you try to skip steps or smush things in, you're going to start to get yourself all sorts of lost. So you just want to take the time to actually write everything out. It can get a little bit tedious, but it's a lot more tedious to have to do the problem 5 times than to just do it once and write out every step. I promise it's for your own good. So we're going to let's start with one where we have common denominators. So let's simplify 3 plus x over x plus 4 over x. So again, we want to remember that since there's addition, subtraction, that is grouped. When you have common denominators, remember that we add the numerators and keep the common denominators. So we have 3 plus x plus 4 over x. Now there's nothing in front of these parentheses that has to be distributed in order for me to get rid of those parentheses, which means I can just drop them. We always want to double check that before we drop parentheses, because if we do have to distribute something, we have to do that before dropping them. But in this case, since there's nothing there to distribute, we end up with x plus 7 over x. Can that be simplified? That can't be simplified, right? Because that x plus 7 is a single factor. And then the denominator has a factor of x, so they don't have any common factors. So this is going to be our basic process. Notice that here I just wrote down what I was going to do without trying to simplify anything. And then in this step, we can actually worry about what that numerator is. Doing it that way allows us to just focus on the numerator and the denominator kind of separately. So we focus first on getting common denominators, and then after we've gotten a common denominator, we're just worrying about simplifying the numerator. So whatever expression we end up with in the numerator.
So why isn't the column x squared?
So if you have a pizza and it's split into 8 pieces, and I eat 2 of them, and you eat 3 of them, how much of the whole pizza did we eat? 5 what?
Slices,
And each slice is how much of the pizza?
a fifth. No, I'm sorry, three-fifths. I have no idea.
So the pizza is split into 8 pieces, and so I ate 2/8 of the pizza, and you ate 3/8 of the pizza, and together we ate 5/8 of the pizza. So the size of each slice doesn't change just because we put them together, right? So, and that's why we get common denominators, is because we can't change the denominator when we add. So we have to be adding things that are the same size so that we can then say, okay, if I have 2 of this and then 3 of this, I have 5 of it. So it's a lot like terms. The denominator of a fraction, all it really tells us is the size of each piece. So how much the whole has been split up into. And that doesn't change when you add things together, right? We don't all of a sudden have 16 pieces when I add 2/5 or 2/8 plus 3/8. Okay, so let's do one where we have to actually get common denominators. I'll start with 2x plus 1 over x squared minus 7x plus 6 plus x plus 3 over x squared minus 5x minus 6. Okay, so adding and subtracting. Rational expressions. The first thing we want to do is to factor our denominators. So we're not going to be able to find a least common denominator unless we can find the least common multiple of our denominators. And in order to find the least common multiple, just like we just saw, the first thing we have to do is factor. So we're going to factor the denominators. So if you guys were actually doing this like on homework and you didn't have me here to do it for you, you would just use go over to some other part of the page and do your factorization, your whole AC method. In the interest of time, I'm just going to factor these guys. So remember, the numerator is in parentheses because it's addition, subtraction, and then the denominator is x minus 6 times x minus 1. And then same thing here. We put our numerator in parentheses because it contains addition. And then this factors into x minus 6 times x plus 1. So now we want to get common denominators. And just like what we do with numerical fractions, the only way to get common denominators is to multiply by a convenient factor of 1, right? So to multiply by a fraction that's the same on the top and the bottom, but contains the factors that you want in your denominator. So we're just going to start by kind of setting ourselves up. We've got our first fraction. And we know we're going to multiply that by something. And then we've got our second fraction. And we know we're going to multiply that by something. And so I just kind of built like a skeleton of what I'm doing. That way I don't have to like try to organize at the same time as trying to figure out like what to put where. So I always start by identifying what factors they have in common, because those factors I don't have to worry about, right? If they have a factor in common, then neither of them needs that factor. So they both have a factor of x minus 6. And then that first fraction has a factor of x minus 1 that the second one does not have. And so I'm going to need a factor of x minus 1 over here. And now they both have that in common. And then my second fraction has a factor of x plus 1 that the first one does not have. So I'm going to need a factor of x plus 1 over here. And now they both have a factor of x plus 1. You can kind of think it's like small children. So if you give everybody a handful of Skittles and one person is like, they have 5 green and I only have 3, well, you can't take 2 green ones away from the kid who has 5, right? You have to give the other kid 2 more green ones. But then they have they have 3 red ones and the other one only has 1, so that kid needs 2 more red ones. So we are looking at the goal here is for both fractions to have exactly the same factors in their denominator, which means that any factors that one of them has in their denominator that the other one doesn't have, we have to multiply by as part of our factor of 1 right here. It's the same on the top and the bottom. Questions?
So when we have the x minus 6 on both sides, that means nothing's going to happen with that because it's already there.
Because they both already have it.
Okay. And then the one that it doesn't have goes on the top and the bottom.
Right, so I mean, when you get common denominators, Like, the only way to do it is to multiply by factors of 1. Right? Like, I can't just, like, be like, oh, I'm gonna make this into 1/6 and this into 1/6, right? Because those aren't equivalent.
Yeah.
So the only way to get common denominators is to multiply by factors of 1. So fractions that are the same on the top and the bottom. So just like when I was doing 1/2 plus 1/3, I'm like, oh, well, 1/3 has a factor of 3 in the denominator that 1/2 doesn't have. And so I'm going to multiply by 3/3. And 1/2 has a factor of 2 that 1/3 doesn't have. And so I'm going to multiply by 2/2.
Okay.
So same exact idea here.
Is it always a factor of 1?
Yes, because multiplying by anything other than 1 changes the value of an expression, and then we just have a completely different expression. Other questions? Delaney, how you doing?
I'm doing good. I get it.
Okay, so now we're going to simplify from here. We have a common denominator of x minus 6 times x minus 1 times x plus 1. So we got that here. And here. What's the problem there, Mike?
The problem is just, seems like we're making it more complicated than it is.
We are. In fact, that's how you add fractions, is you unsimplify them. Just like if you were adding 1/2 plus 1/3, and you multiply by 3/3 and 2/2 to get 3/6 plus 2/6. Both of those fractions are unsimplified versions of the ones that we had. The only way to get common denominators is to unsimplify fractions by putting in factors that you don't need if it was just that fraction on its own, but you have to have in order to make the denominators the same.
So I'm assuming the reason why we're doing step 2 like that is because it gets more complicated.
What do you mean?
Well, I mean, because I could look at 2x plus 1 over x minus 6, x minus 2, and say, okay, well, I just need to add an x plus 1, and there's my denominator.
Right, but you can't just put it in the denominator. You have to multiply by a factor of 1.
Right. Never mind.
Like, we can't, like, even if we know what the denominator is going to be, we still have to take the entire fraction into account when we get common denominator.
Right. I'm with you.
Okay. So, go ahead.
Or could you, so in any one of these like type of problems, could you just like look at the other one, and if it's not there, then you switch and you know you need to multiply by that?
Well, that's what we did.
Yeah, I know, but could you do that with every one, or are they gonna get more complicated?
Yes and yes. They can get more complicated, but you still do the same thing.
Oh, okay.
Because that's what I was trying to
So we've got our common denominator, and then our numerator, we're just gonna rewrite it, like literally copy it, like this whole thing, including the addition sign. So we've got 2x plus 1 times x plus 1 plus x plus 3 times x minus 1.
And you can combine like terms. And I can't because they're in parentheses.
So the big question is, can I go like this?
No,
Why not?
because we're adding and you can't get rid of the denominator.
Very good. So I can't cancel there, right? Because of that addition. Remember that the only time you can cancel is when your numerator and denominator are in factored form, which means the only operation outside of parentheses is multiplication. So because we are adding, because of that addition, you don't get to cancel anything. I mean, otherwise you just end up right back where you started. So at this point, so remember how I was saying before, we can kind of separate things so that we're focusing on the numerator or on the denominator and then on the numerator. So everything we've done so far is just about making the denominator the same. And now everything we do from here on out is going to just be about simplifying this expression. So all we're going to do at this point is simplify the numerator the same way that we simplified polynomials like 2 weeks ago. Right? In fact, I think we had some that looked really similar to this. So we're going to distribute 2x squared. So I dropped the ball on my list here. Add, subtract, numerators. Keeping the common denominator. And then we're going to simplify the numerator. So let's see, 2x squared plus 2x plus x plus 1 plus x squared minus x plus 3x minus 3. So technically, this guy and this guy are still in parentheses. However, notice there's nothing to distribute. There's no like subtraction between those two sets of parentheses. And so I don't actually need them in this case because it's all addition. And then that is still over my common denominator. So now we've gotten rid of parentheses. We can combine like terms. So I have 2x squared plus x squared is 3x squared. 2x plus x is 3x, minus x is 2x, plus 3x is 5x. And then minus 2. All over our common denominator. Any ideas about what to do next? Yeah, we're going to simplify that fraction if we can. So we're going to factor the numerator. And simplify fraction. I'm out of room, so I gotta move this guy. So let's see, AC is -6, B is +5, so 6 and -1. So that means this is 3x minus 1 times x minus +2.
Oh, because we factored the denominator, we haven't factored the numerator yet.
Right.
Okay.
Because we can't factor the numerator until it's completely simplified.
Right.
And that's all well and good that factors, but it doesn't actually help us simplify the fraction at all, so we're just done. Well, if you could cancel common factors.
Oh, so if you had a x minus 1 up top, just like we canceled before
Yeah.
with division and multiplication.
Uh-huh.
So you can do that just at the end of the problem when you're simplifying the numerator.
Right. Well, you can't do that before this point because there's addition,
That makes sense.
right? So once we've completely simplified the numerator, then we just have a single rational expression, just like we did on Thursday. We can factor everybody and
Okay.
simplify. Okay, let's do another one.
And you thought the multiplication division was
Um, let's do this one. 2. Okay, so just like we did on Thursday, we're going to just start by putting in parentheses where there's addition or subtraction. And the next step is to factor the denominators, but in this case, there's no factoring to do, right? The first one doesn't have an exponent, the second one doesn't have an exponent, so neither can be factored. There's no GCF to take out. So now I'm ready to get common denominators. So we're just going to set it up. Okay, so the factors in my first denominator, well, there's just the one, is a plus 2. And then my second denominator has a factor of 2 and a factor of a. So what should I multiply the first fraction by?
2a.
2a over 2a. And what should I multiply my second fraction by?
A plus 2.
A plus 2 over a plus 2. And remember those parentheses. So now we've got our common denominator, which is 2a times a plus 2. And then 2a times 2a plus 3 times a plus 2 in the numerator. So we've gotten our common denominator, now it's time to focus on the numerator. So we're just going to distribute. Oops. So 2a times 2a is 4a squared, and then plus 3a plus 6. And that's all over our common denominator. And that one's done. And the way that I know it's done just by looking at it is that everything's positive. And if everything's positive, like AC is way too big to have factors that add to 3. Right? The only way for us to have factors that add to 3 would be if one was positive and one was negative. And that's not the case here because everything is positive. And so that's not going to factor. Notice that even though in both denominators we see an A and a 2, that doesn't mean that they're like the same. We have to be careful about what we have as factors and what we have as terms, right? Because there's not anything that we could multiply A by to get A plus 2. It's just a separate factor. Questions on this one? Okay, here's one for you guys to try.
What was wrong with the first two?
What?
What was
I
wrong with
thought
the
it was
two?
ugly.
Come on.
Everybody get to that point? We figured out what we need to multiply by. And then we have x plus 3 times x minus 2 times x plus 4 over x times x plus 4. And then, yeah, like Mike was saying, like you can put the x in front here if you like it better. But it distributes the same either way. So we have x squared plus 3x minus 2x minus 8.
So why don't we distribute the x on the bottom again?
So the only reason we distribute in the numerator is because there's that subtraction there. And in order to get like a single polynomial that we can factor, we have to like be able to combine like terms because of that subtraction. But the denominator is already a product, right? Remember, our goal when we simplify a fraction is to have the numerator and denominator both written in factored form. So if the denominator is already in factored form, then we don't have to do anything to it to get to that point. Whereas with the numerator, because of this subtraction, the only way we can get to factored form is to distribute, combine like terms, and then factor. Kind of like when we were solving equations the other day, right? When we like had like something that was factored, but it was equal to like 5, and we had to subtract 5 from both sides. The only choice we had was to distribute everything, put it all together into one polynomial, and then break it up again. Does that answer your question?
Kind of.
So I mean,
Well, I understand that if we want the bottom in factored form, okay,
right.
all right.
Because that's the only way to simplify a fraction, is if it's factored. If the numerator and denominator are both factored.
Okay.
I'm with you. Scooby-Doo.
So I'm going to combine like terms here.
So you can have x3 minus 8.
Plus x minus 8. Because 3x minus 2x is 1x.
Can't you put x3?
No, because remember, this is
It's not
like the
terms,
hundreds place
yeah.
and the tens place, right?
Yeah, like terms.
So could you not like factor like the first two and then the second two?
You could, but you would get right back to this step right here.
Right.
And that's like a really common thing, is that we're so used to like writing it with 4 terms in order to factor it that we're like, oh, it already has 4 terms. But remember that we have to write it with 4 terms in a really specific way in order to factor. And so we have to put it together first and then use our AC method to see if we can pull it apart. Which again, in this case, we can't, because AC is -8 and there's no factors of -8 that add to 1. And that happens fairly often, that you just can't simplify from here. Mostly because we use the least common denominator, so we don't have a
You're
bunch of
already
extra factors
Kind of simplifying.
floating around. Yeah. Okay, so let's do this one. Let's simplify. 2x over x squared minus 4 plus 5 over 2 minus x minus 1 over x plus 2. Okay, what do you guys want to do first? I mean, after parentheses. Sorry, I'll do that first.
Well, you gotta get a common denominator.
Okay, in order to get a common denominator, what do you do first?
Find that LCM.
How?
You're gonna have to, can you factor those out and then put them together?
So we're going to factor our denominators first. X plus 2, x minus 2. And then what about the second one? Okay, so I rearrange it to get what?
X minus
But
X
2
plus
minus...
2, so-
Well, so the x is negative, and the 2 is positive.
Right,
So negative x plus 2. And then what?
1.
Factor out -1. And then minus 1 over x plus 2. Okay, so at this point, there's something we can do that will make our lives way easier,
That's what I'm about.
which is to take this factor of -1 and move it to the numerator. Do you guys agree with me that dividing by -1 will always get you the same thing as multiplying by -1? Because like dividing by -1, it just changes the sign, right? And doesn't multiplying by -1 also just change the sign? So like 5 times 1 over -1 is the same, is the same as 5 times -1 over 1. So these two fractions are exactly the same. If you have -1 in the numerator, it's the same as having it in the denominator, because multiplying by -1 and dividing by -1 are exactly the same thing. All they do is change the sign. That's only true with 1, by the way, because if it was a 2, dividing by 2 and multiplying by 2 are not the same thing, right? But multiplying and dividing by the number 1 are the same thing. You end up with the same thing either way. And so we are going to rewrite this. Now that we're ready to get common denominators. I'm going to write this as -1 times 5. Anybody okay with me just like writing it as -5?
That would be easier.
Is that okay? And then 1 over x plus 2 times something. So the reason we did that is that if you have a factor of -1 in your LCM, then we're going to have like, we would have to do -1 over -1 in the first fraction and -1 over -1 in the last fraction. And all of a sudden we have like 5 factors of -1 floating around that we have to handle throughout the whole problem, which is a lot more complex and leaves more room for error than just having that one factor of -1 in the numerator. So rather than like having factors of -1 everywhere in sight, we're just moving that single factor up so it's not part of our LCM. So here I don't have to multiply by anything, right? Because my LCM is going to be x plus 2 times x minus 2. So if it makes you happy to do this, then you can do that. Or you can just leave it out altogether. Here I'm going to need an x plus 2. Here I'm going to need an x minus 2 over x minus 2. And so we have 2x minus 5 times x plus 2 minus 1 times x minus 2. And that's all over x plus 2 times x minus 2. And now we'll distribute. So 2x minus 5x minus 10 minus x plus 2 all over my common denominator. What is that? -3, -4. Oh, this is exciting. So then we have factor a -4 out of the numerator. And then my x plus 2's are going to cancel. So we end up with -4 over x minus 2. It's always so exciting when things cancel at the end after all that work. What's wrong?
So I got a little lost in the beginning.
Okay.
With the 2 minus x,
Yes.
and we were turning, like, wouldn't that end up being -x plus 2?
Mm-hmm. But then remember that we want a positive coefficient in the first term, so we factor out a -1, which changes the sign on both of them.
And then the 1,
Just like we did on Thursday.
and then the 1 just went upstairs to 5 and made it a -5.
Right. So, I mean, you can think of it you could think of it as like we divided 5 by -1, and we got -5. And so that's what our numerator is. Like, the upshot of the whole thing is that dividing and multiplying by -1 achieve the same thing. And so we can multiply in the numerator by -1 instead of dividing by it in the denominator. Because otherwise, like if we keep it in the denominator, then you're going to need a -1 here, a -1 here, a -1 here, and a -1 here, to like so that they all have that factor of -1 in the bottom. I mean, I don't know about you, but that looks like a huge pain to me to have all those -1s floating around. So we avoid that by getting it out of the or out of the denominator.
So if you left the x minus 2 in parentheses, would that be considered wrong? Or
No, that's fine. Yeah, that's totally fine. Okay, let's do a couple more together, and then I'll let you guys work on your homework a bit. Again, really the key to all of this is just like organizing and like not like rushing through all the steps. Is like if you can keep everything sort of like all laid out nicely, then it's a lot easier to manipulate. Okay. Let's do we'll do this one, and then we'll do that other one, and then we'll be done. Let's go x minus 1 over 3x squared plus 15x minus x plus 3 over 6x plus 30. So again, we're going to start with factoring both our denominators. So I've got x minus 1 over 3x times x plus 5. And then x plus 3. It's really ugly. X plus 3 over 6 times x plus 5. And then just like we did on Thursday, remember how like if we had a monomial factor, we did the prime factorization of it? So we can think of this 6 as 2 times 3. Because we don't want a factor of 3 and a factor of 6 when we get common denominators, because that factor of 6 already has a factor of 3 in it. So now we'll set this up to get common denominators. So we've got 3x times x plus 5. I'm going to multiply by something there. And then x plus 3 over 2 times 3 times x plus 5. What should I multiply my first fraction by? 2 over 2, good. What should I multiply my second fraction by? X over x, good. So remember with those monomials, those are all separate factors. So we had a factor of 3, oops, a factor of 3, a factor of x plus 5. Here we had a factor of 2, a factor of 3, and a factor of x plus 5. So we've got 2 times x minus 1 minus x times x plus 3 all over 6x times x plus 5. And we're ready to distribute, so 2x minus 2 minus x squared minus 3x and combine like terms, so negative x squared minus x minus 2 over 6x times x plus 5. And then we can factor out a negative 1. Which shows us that we can't factor any further because all of those coefficients are positive, right? There's no way I can get factors of 2 that are going to add to 1 if they're all positive.
So you have to make them positive?
So when you factor out the negative 1,
Mm-hmm.
that's going to change the sign on all 3 terms.
Does that first term have to switch to a positive though, or could you just leave it like that?
If you knew it wasn't going to factor, you could leave it. But if you're going to factor, like we always want to get that positive first term. Other questions? What?
Skip the step.
What step did I skip?
Well, the negative 1. Better thinking of I don't know.
So from here to here, I just factored out a negative 1. Like a GCF of negative 1.
Can you show me again how we got 6x parentheses x with psi for our denominator?
So I just multiplied the 2 and the 3 to get the 6.
Okay. And then we got the x from the other side.
Yeah, so here we had a factor of 3, a factor of x, and a factor of x plus 5. Here we had a factor of 2, a factor of 3, and a factor of x plus 5.
Yeah.
So they both had these guys. So the one on the right was missing this, and the one on the left was missing this.
Okay. I guess I feel like that should be just 2x then.
Like this should be
Maybe I'm
2x?
understanding something. No, not that.
Like in the denominator?
Yeah.
But like if you look at this right here,
Uh-huh.
do you get 2x?
No.
Don't you get 6x?
Uh-huh.
I mean, what we get here is just what this is. You know, like there's no like manipulation to like what you put in your common denominator. You just put together all the factors. And the only reason it looks different in this case is that like I multiplied the 2 and the 3 just because they're monomials, and I'm cool with calling 2 times 3 6.
Okay.
Like it doesn't, just like we did on Thursday, right? Like with monomials we did prime factorization, but with whole numbers we always multiply the factors that we have left. Just like when you guys like factored something like this, right? And you had 2 times 2 times 5, and you had 2 times 2 times 3 times 5, and you canceled, right? Damn it. That's a bad example. 90. So 2 times 2 times 5, and then we had like 3 times 3 times 2 times 5. Right, like when we got there, like you wrote that as 2/9, right?
Yes.
So same deal, just like because they're whole number factors, we can actually like multiply them together without affecting our ability to simplify the fraction later on when we get to that point.
So you really have to do the -1 at the last step. I mean, it's the same either way. One, you're just, if you did
So the first step to factoring a polynomial is to put it in descending order and get a positive first term. You don't know if that factors until you try to factor it, right?
I guess.
So if you just leave it like this, you haven't tried to factor it yet. Like, what you're saying is only true if x squared plus x plus 2 doesn't factor. And if you tell yourself, oh, I don't have to factor out the -1, then if that polynomial did factor, you would miss it.
Right, but I feel like, because if you go to the last step, well, you're not done really, because you should -1 into x2, which then gives you back to the same problem which you just converted.
What do you mean you're not done? I don't know what you mean. You mean you want to distribute, but we don't distribute.
No, I mean, but
Just like we don't distribute this.
if you finish the numerator on the last problem, it would convert back to the.
But the word finish, I think you're using incorrectly here. This is finished. Just like this is finished. Because it's factored. And that's how we leave rational expressions, is in factored form. The only way you're going to know if this factors is to actually try to factor it. And the first step to doing that is factoring out a -1. If you don't factor out the -1, then you'll miss it if this ends up
I
factoring.
get that back. To me, it doesn't look finished with the -1 out there.
But I mean, does this look finished to you?
Sure.
But that's the same thing. Like it's just in factored form.
Okay.
Like it's a factor
Because
type.
I'm getting, there's a coefficient with no term. You know what I mean?
Yeah, both of those have
I get what you're doing.
have
I just-
monomial
I just don't
GCFs
understand why that's finished. To me, it doesn't look finished.
because it's factored. So when we try to simplify a fraction, we factor the numerator and we factor the denominator. This is a perfectly acceptable answer, but what I'm saying is that if you don't try to factor the numerator, then you don't know if it factors or not.
Okay, now I understand.
Right? Like, this didn't happen to factor, but if it did and you didn't factor out the -1, you wouldn't know that. Okay, let's do one more. Hey, Alex, could you swing that door shut for me, please? Thank you. Okay, let's simplify. x plus 5 over x minus 3 minus x plus 2 over x plus 1 minus 6x plus 10 over x squared minus 2x minus 3. Okay, so again, we're going to just start by putting our parentheses and then factoring those denominators. So we have x plus 5 over x minus 3, x plus 2 over x plus 1, and then 6x plus 10 over x minus 3 times x plus 1. So far, so good? So now we're going to get our common denominators.
Wouldn't we like factor out a 2 from the 6x plus 10?
Nope, because we're only factoring the denominators. Because remember that when we get here, we distribute everything in the numerator. Right? So if we factor the numerator just to distribute it again, we would be undoing what we did. Okay, so we've got x plus 5 over x minus 3 times something minus x plus 2 over x plus 1 times something, and then 6x plus 10 x minus 3 x plus 1 times something. So it looks like that first fraction I need an x plus 1 over x plus 1. In the second one, I need an x minus 3 over x minus 3. And then the third one, I don't need anything. If it helps, you can kind of like group these guys. Like in between the addition and subtraction. So you can kind of see those as individual denominators. So anything, we want all of them to have the same denominator. So we want them all to have the same factors. So since this guy has both an x minus 3 and an x plus 1, then the rest of them have to have both an x minus 3 and an x plus 1. And so that first fraction needed a factor of x plus 1, and the second one needed a factor of x minus 3.
It's not always going to be like that, right?
Like where one of them already has all of them? Mm-hmm. Right, like so sometimes...
But I'm saying like it was like 3x times x plus 6, and then it was 6x plus 7 or something. On the other side.
Like if they're totally different?
Yeah.
then they each just need what the other one has.
Oh, okay.
So like if you had like 1 over like x plus 5 plus 3 over 2x minus 3, then we'd need a 2x minus 3 here. And we'd need an x plus 5 here. Okay, so now I'm just going to write out, oh, go ahead.
Would you multiply the 6x plus 10, that like set by 1/1?
Yeah, if you want to. I mean, we can just leave it alone, but if it makes you more comfortable to do something, then that's fine too. So we now have x plus 5 times x plus 1 minus x plus 2 times x minus 3 minus 6x plus 10. So we have to be really careful here with signs, especially here when we multiply those two polynomials together. We haven't distributed the negative yet, so the result is going to stay in parentheses. So we have x squared plus x plus 5x plus 5 minus x squared minus 3x plus 2x minus 6. And then this is another place where you want to be really careful. This is one of the reasons that I always put those parentheses in at the beginning, is that we have to distribute that negative to the 6x plus 10. If you didn't have parentheses around your 6x plus 10, that's easy to lose. So this is minus 6x minus 10. And that's all over our common denominator. So we've got x squared plus 6x plus 5, and then negative 3x plus 2x is a negative 1x. So when I distribute this, I'm going to have minus x squared plus x plus 6. And now I just have to combine like terms. This actually works out kind of nice. So these guys go away. And then we have 6. These guys go away. So we have x and then plus 1. I'm running out of room a little bit, but didn't that work out nice? So pretty. So a couple things, again, like I said, be really careful with those parentheses. Make sure that you put your parentheses in at the very beginning so that everything is grouped correctly when you get to combining things. And make sure that you write your denominator in every single step, even if it feels redundant, because when we start clearing fractions to solve equations, we will lose denominators, and it's very easy to mix up the two processes if you don't write your denominators in every step here. You start thinking you lost your denominators. What's up, Mike?
You're changing signs twice.
Where?
Well, the middle term.
So negative 3x plus 2x is negative 1x.
Well, you already changed. No, okay, so you didn't change terms there.
So all we did
Yeah, I see
in the
what you
first
mean.
step is distribute.
You didn't, yeah,
Okay, you guys ready to do a couple before you go?